Hello, hello. Welcome to another episode of No Lits, No Limits. My name is Kin from Canada, and I've got my good friend here, Phil, also from Canada. Phil, how about a little introduction about yourself?
Hey Ken, how you doing? Thanks for having me on today. Glad to be here. Great stuff, man. Yeah, I'm another veteran like you. Been at this manufacturing thing for quite a time. All right, across Canada, through the states, building factories, getting my hands dirty, doing all that kind of stuff, ins and outs and backwards and forwards and ups and downs and all over the place. So had lots of fun and ready to talk a little about
Yeah, Phil and I go way back. My gosh, too
it.
long. We won't mention it. It makes us feel so old, but
Couple of
we
years,
used to
couple of
work
years.
together. Yeah, in many different scenarios. You and I probably connected one of my first jobs, one of your first jobs out of school almost, right?
Yeah, I'm pretty sure it was right out of school for myself there. Yeah. We worked
Yeah.
together at a couple places and would started from an empty warehouse and banged a few heads together and got things up and running. It was a lot of fun.
It was so intriguing at the time when we started our careers. SMT was so new technology back then, and I'll allude to the audience that it's somewhere in the 90s, right? That we
Somewhere
started.
along there, yes.
We're that old, but SMT was something so new at the time. We're gosh, like 30 plus years now since that time. What are the big transformations that you've seen, Phil, in your time working in this industry?
Well, I mean, you can remember some of the equipment, the machines we worked with, right? And a lot of the stuff we did. And like I say, nobody else knew how to do it. Here's something here. We figure it out. Let's bash our heads together and see what's going on. And if we could produce 2 or 3 boards in a day, hey, we were laughing. We were
Yeah.
happy, right? Look at this line's humming, right? And away we go, you know? And then you come to today and the differences in equipment and that kind of thing. If you're not producing 10,000 boards a day, then you're in trouble. So the change in that aspect and in the volumes that you've seen and the equipment, the capabilities are just very expansive, right? On the changes that have happened in, like you say, in the last 30 years.
So the change that you happened, do you think that was a case where consumer demand drove the build more, or was it the fact that we could build more that enabled companies to produce more products for the masses?
I think companies are always looking, you're always looking to get more out of your equipment and more what you could do. And it's just a gradual over time improvement on the equipment allows the management to get a little bit more out of their investment. We can do a bit more today, a bit more tomorrow. And I mean, you want to get your resources to be able to get to produce as much as possible, right? Without, having to double your, your investment, so to speak, right? So, it's the same old things that you talk about. Oh, computers are coming. We're going to have a 3-day work week. Well, no, we still have a 5-day work week. We just have to do four times as much, right? So it's similar with the manufacturing.
In terms of comparing the 2026 to back in the 1990s, what do you think are the things that have changed a lot? And what are the things that stay common since 30 years ago?
The technology obviously is changed quite a bit, right? The ability to the equipment these days is just the software has taken over the equipment itself. And we'll get into AI a little bit on that as well, right? But just the ability to process the knowledge, the ability to handle the components and what we're doing is 100-fold or more from what it was, right? What's stayed the same is you still need those people, right? You still need somebody to look at it and manage it and decide, hey, we're going to do this today or that tomorrow, or make those decisions in the background on what's going on, what's going to happen, and give some direction to your process.
Right. One of the hot topics that everyone's talking about nowadays is AI, AI this, AI that. How much does AI, do you feel, factors into making manufacturing better or easier or faster or cheaper?
I think it's in its infancy. It really is, right? A lot of the guys are not aware of how powerful it is yet and what it can do. That's another one. It's going to change everything we're doing, right? Again, it's going to make things faster, or it's going to make us more efficient, right? It's a matter of learning what it can do. A lot of the guys, like I say, are still on that cusp of grasping that and what they could do. I think back to the old place. I don't go back to, pre 2000s again. One guy's got a piece of paper, right? And he's sitting there and he's coloring. I'm like, what are you coloring? Oh, this is my components of my board and this is where it's supposed to be. Right. I said, well, what happens when that changes? He says, oh, well, I sit down and I make a new one. And along comes Word and Excel and all this. And all of a sudden that guy that's spending 10 hours doing these color drawings can do them in, 3 minutes. And it's the same thing too with this AI that's come along. These guys that are doing these manual tasks now, right? And it's taking up time, and I think they're being efficient at the moment. It's going to disappear. Those tasks are going to be obsolete, right? And they're going to be freed up to be able to do other, you know, other components of their job and what they're looking at.
There's been a lot of talk about robotics in electronics manufacturing. Do you see that happening? As in, like we have these humanoid robots running our SMT machines?
You talk about, we go lights out factory, right? Humanoids and that. We're going to get there. Yeah, we're going to get there. There's still a lot to be figured out. I think it's going to happen again faster than we think, but it's just that you're going to have that human element. Okay, what do I want these robots to do in my factory? What are their tasks? What's defined, and how should they function within an efficient part of what I'm doing, without just running blind? We're going to have
Mm-hmm.
to look at them and how we're going to use them properly and what can be done. There's definitely tasks in there that can happen, and jobs that they could do quite well, better than we're doing ourselves. But again, you talk about wanting to keep that human element in there. We're going to have to watch what they're doing and define those jobs for them properly on what's going on the floor.
A lot of the automation equipment we use today themselves, I've always considered SMT pick and place machine or a stencil printer as a purpose-built form of robotics. What difference might an actual humanoid robot or roving robot do on an SMT line that the machines couldn't possibly do today? Where do you see the big transformation that would really enable this to happen to get closer towards the lights out factory?
Well, you say SMT is a very stable process, and it is for, like we go back a number of years again on what's going on, but you still need somebody to run those machines. You still need somebody to fill those feeders, to do that little bit of debug on what's going on. Bring those parts from the warehouse out to the machine when you need the next kit, set up the next batch of feeders, right? Whether we get down to the loading the feeder aspect, I think we will, but that may be a little farther. But, looking at the next job, organizing the next job, bringing those parts down to the line, and getting that set up ready to go. Well, there are a lot of tasks that people are just used to doing. I still see a lot of paper sheets. Like, I was using paper sheets on this. That's got to go. It's gonna go, right? These are tasks we can have these robots easily, set up to do, and again, freeing up people, freeing up resources, right? Doing a defined task and helping those factories be a lot more efficient that way.
I mean, speaking of efficiency and utilization of resources, at my workplace, we've had a recent conversation about how we really need to groom our people that operate the machines, our SMT operators. Instead of having people running the machines, we have people that keep the machines running. And that's a very important pivot in concept is, having people keep the machines running. So the machines more or less run themselves rather than people sitting there running the machines. What is your take on that?
It's happening now. Okay. The machines for quite a number of years now have been spitting out data. They've just it's been sitting there. The machines are going, I've got it. What do you want to do with it? Now we have these AI tools. And this is where we're on the cusp of taking things over, that these tools can take this data, okay, and they can tell us what's happening. Not just when a feeder runs out, not just the board's gone through the machine, but we can look at a screen printer and an SPI and the trend. Am I printing properly? Am I not? Do I need more solder paste? Do I need to adjust this? And those changes are made automatically based on the data that's happening without the operator in any kind of intervention. You've got machine to machine learning, machine to machine interaction between your screen printer, your SPI down to your placement machine. Okay. Your placement machine down to a post placement AOI can feed back to the mounter. Do I have a bad nozzle? Do I have a clogged nozzle? Do I need to take this head out of rotation so I'm not placing bad parts anymore? These are all tasks that were assigned to operators before. They're now part of this interactive preventative process that's taking over. Basically, it's coming fast on what's going to happen with this equipment. So that back and forth and that communication that's happening between the machines without the operators even knowing is going to be the next big step.
So what you're saying is essentially the process need to be there before you really introduce more automation because it sounds like if your process isn't there, then all your automation is going to do is just going to let the process break down even faster then. Is that true?
That is true. You have to be able to control what you're building, look at what's going on, and have that proper setup going. You've got to have the right feed in the right place. You can build an awful lot of bad boards if you put the wrong feed in the wrong location. Those machines are running. We've seen it, but you're correct. You have to be able to set up your processes in the front end all the way down the line and make sure everything's stable.
Definitely. I guess this concept of Lean Six Sigma to really define the processes so that they are operated without waste They're operated sort of at the peak efficiencies to eliminate any excess movements, excess transportation, excess defects, and practicing some of the Toyota production systems and-ons where you stop the process if something goes wrong, fix it right away, and then keep going. I mean, that's probably I think where you're coming from with fixing the process, right?
Correct. You go back to the it doesn't have to be complicated. Plan, do, check, act. You can have the tools of what's going on, but if you don't make that plan in the beginning to get things going, then you're going to have a lot of problems down the line before you know it.
Definitely. The PDCA is so important because it's the plan, it's the do, but the check and the act is that feedback loop, which drives that continuous improvement aspect of the process. Where do you see some of the challenges today with the newer technologies where process engineers really need to focus?
A lot of a mixed technology. Your parts get a lot smaller, your parts get a lot bigger. Seeing components that are the size of a grain of salt on a board, along with components that are a kilogram in weight, believe it or not. They're just massive. So, how do you process these? How do you print enough solder paste for the large one and not too much for the small one? How do you set a thermal profile for that? So these
Mm.
technologies, these mixed technologies, we're going bigger, we're going smaller at the same time, larger boards, smaller boards. These are the real challenges of your process engineers today on these complex assemblies that you're seeing. We're talking when you're getting into data centers, this kind of thing, thousands and thousands at a time.
I can imagine with data centers where you're building these very highly complex boards with these super expensive GPUs that you have to solder onto these boards at many layers thick. That could be extremely challenging for thermal profiling and placement. Have there been other technologies beyond our improvements in pick and place, obviously to be able to handle these smallest of the small parts and the biggest of the heavy parts? What about in areas of conveyor systems, board handling systems, or even right down to the reflow oven? Where has some of the technology evolved in those areas?
Board handling systems, a lot of, multi-layer boards, a lot of copper, a lot of heavy 10 kilogram boards. So, I mean, that wears a lot on your bearings and your belts and that kind of thing. So a lot of the equipment manufacturers now have options for 5 kilograms, 10 kilograms, 50 kilograms if you really want to. So the options are out there as far as, heavy duty belts or chains, heavy duty bearings. You just got to look ahead of time on what you need and what you want to plan for down the line.
What about in the area of reflow ovens or soldering systems? Are there any new technologies that we should look forward to?
You have nitrogen has been around for quite a while in your reflow ovens. Now you're getting into with your larger components, you're seeing some voiding in the solder and that kind of thing, especially on your leadless components, this kind of thing. So now you're into vacuum reflow ovens. Okay. You actually have a vacuum chamber inside the oven, so at the reflow point to be able to pull those voids, pull those gases out of the solder and minimize your voiding. So your reflow ovens are getting more complex as well.
I can see how that gets complicated very quick when you have a vacuum system in those ovens.
Correct.
Yeah, what about in areas of wave soldering or selective soldering? Do people still use a lot of those for through hole?
Wave solder, you don't see too much, not so much nowadays. Selective solder a lot more because your through hole still hasn't disappeared. They were talking about before you and I, through hole's gone. No, it's still here, still effective. It's kind of like radio. Radio's gonna disappear now. Radio's still here. So you do have through hole components, a lot of power components, a lot of large items like this. So you're looking at systems that are able to integrate all the systems. You got heavy duty fluxing systems, IR and hot air systems for your preheats. And then you've got single pumps or dual pumps, be able to do lead free and leaded as well. Right. And the nozzles actually on the selective solder machines are getting quite complex now too. Instead of just a single pinpoint nozzle, you can get mini wave nozzles. Okay. You can do for selective connectors and such. So there's quite a bit of technology there as well to really be customizable as opposed to the old wave solder machine with 2,000 pounds of solder and one wave to go over and trying to adjust your fixtures. You have a lot more options with your selective solders nowadays.
Soldering has always been one of those messy things in our business. Everything from cleaning that dross out of the wave solder to just being able to work with it and tune the process. Do you think soldering itself is ever going to go away?
Everybody said it was going to disappear with lead free and it's still around. No, I don't think it's going to disappear. It's just such an efficient way to make that mechanical joint. It's mechanical, it's electrical, it gets that component onto a PCB and makes sure you complete your circuit. I don't see it disappearing. No. Now, there's different ways to apply it. You have your selective solder. I've seen we get past again, past SMT and into the back end, right? A lot more different complex assemblies and that kind of thing. Laser soldering, white light soldering, different ways to apply. Once you get into some of these materials that cannot handle the heat of a reflow, you want to look at specific locations or applications like that. Um, a lot of these automotive is really good at it as far as customization, where you've got components inside a molding that you've got to get at. And you've got a laser machine that can pinpoint that exact solder joint, give it a couple seconds, and away you go. So there's different applications you solder. It's not going to disappear, might change a little bit, but you've got to get a little more creative on what you're doing.
I was working with one of the local universities here and looking at research of potentially doing additive manufacturing process. So
Mhm.
think 3D printing of
Yep.
circuit boards. And I know there's been a lot of research done in that area. Have you seen anything in your practice in terms of additive manufacturing techniques as opposed to doing soldering or anything like that?
There's a few different avenues. I've seen a couple systems that use additive manufacturing to actually create the entire PC board. The only issue they have is the material they're using is only good to about 140 degrees Celsius. So when it's reflow, you're kind of out of luck. But
Yeah.
I see in a lot of equipment is, say additive to a PCB, guys that are building stack components on a PCB. So the ability within one machine is to the board that comes in, use a dispense valve to lay down the solder paste, put a component down, lay down more solder paste on top of that component, lay down another component, stacking components. I've got some guys doing satellite applications. They've got 4 or 5 components stacked, one application. Okay. Guys that are doing fencing and shielding with, solder paste applications. So this getting a little more complex in your SMT assembly and be
Mhm,
able to do
mhm.
that on the same platform, the same machine doing multiple applications.
Wow, that's pretty fancy. Is that like a package on package or?
Package on package on package on package.
So, are there actual height limits or layer limits when it comes to POP type assemblies that you're aware of?
What you're really looking at, it just comes down to the limitations of the assembly equipment. Is there a limit in the z-axis as far as the head can reach? How high it can it go up? When you're stacking, you're talking about maybe over 4 or 2 components and this kind of thing. So it's not too high. You're getting into complex assemblies and you've got large automotors with large heat sinks and that kind of thing. You get into 3, 4, 5 inch components. But again, you might be a bit customizable, but there's ways around it with different equipment and different platforms to be able to handle these custom assemblies, let's say. And there's a lot more of these EVs and that kind of stuff. A lot of challenges that way that the guys are tackling right now. It's very interesting.
These kind of different types of advanced technology assemblies you describe. Obviously, it's still going to take some very good process engineers to review them, to figure things out, how to program the machine. What about programming's aspect of our automation equipment? How much has that changed with introduction of maybe some AIs or machine learning in this industry?
Absolutely. It's changing leaps and bounds. The days of creating your package libraries and maintaining that. And if you wanted to switch from one machine to the next, you're ripping your hair out and spending weeks on end. It doesn't happen anymore. You can easily nowadays, the machines are, I kind of think that Henry Ford and stabilized his process. Machines are all very similar and all made the same. You can actually transfer libraries from machine to machine to machine much more easier these days. Machines are able to run their process, use the vision systems that they have for assembly, look at the mistakes they're making. Okay, this package is a little bit bigger than I thought, a little bit smaller. Let's adjust here. Make these adjustments on the fly, feed it back to the library, give you that loop to be able to optimize your process, whether it be false calls for an AOI, whether it be a pickup package on an SMT machine. But that feedback loop again back to that library, you're not manually trying to have it update everything all the time. It's doing it for you without even seeing it. It's feeding it back to your library. Now that's one you've got to be careful in your process. What am I changing? How much am I going to allow? But once you get that stable, once you get it set, those systems nowadays are able to keep your libraries up to date. And that allows you to do things like auto programming. I can sit down, I got my library, I can program my board and be up and running in 10 minutes. 10
Hmm.
minutes. I
10
know
minutes.
you're going to
Wow.
challenge me on that later, but that's okay. I'll show you how. No,
Well, the last time I did a 10-minute program, I probably have flunked a whole bunch of stuff going, that shouldn't have gone that quick. Good point that you've emphasized is everything you've described, Phil, it still keeps the human in the loop. No
absolutely.
matter how far the automation goes, no matter how far AI takes this, it sounds like there's always a human in the loop. That's a pretty important aspect, isn't it?
It goes back again to the days that you and I we're setting things up. How do you want to do this? Let's try and see what happens. If it doesn't work, we don't do it. If it does, we've learned something, away we go. You know, yes, we have more data these days. We can see what's going on. Yes, the machines are learning on their own and managing that process, but they're still doing what we're telling them based on the data. We still have to be there outside the box going, hey, hang on a minute. Is that what I want? Is that what I wanted to do?
Mm-hmm.
Maybe not. Maybe I want to try something over here. Let's try this a little. Well, your data is out of whack. Yeah, but I don't know if I don't try.
I think this is one aspect I think of working with very smart engineers and interns. The human in the loop is important because you're actually seeing things that you didn't expect. It's the unexpected outcome. Oh, I did this. I didn't expect that outcome. To most machine algorithms, including machine learning algorithms, like they would just get confused and go, I don't know. Whereas a human, we're saying, well, we got to do our job, so we got to figure it out,
Figure
even
out
though
we
we
need an
don't
answer.
know.
Yes.
Yeah, we have to go and dig a little further and ask the five whys or whatever it takes to get there. So that's a very important point to keep in mind. The other point that I got from what you just said, Phil, it sounds like a 90-10 rule. Let the algorithm do 90%, but the human is still there to determine if the ultimate result is good enough or is the correct expected outcome. That's the 10% of the work we end up doing. Hopefully, the AI or machine learning algorithms are that good to be able to pull 90% of the effort. And
Exactly.
that's where the real game changer is, isn't there?
Exactly. That's where it is. It's like when your little one hits about about a year old, and he starts walking. You let him take a few steps. Oh, go this way. No, go this way. All right, we've got to be there. We've got to steer a little bit. Let it try and find its way, but we got to show it where to go and what to do.
One of the things at my current workplace right now is we're trying a lot of things to test out where the AI can help. The curiosity and the courage to innovate and test things. I mean, how much of this do you think is going to really help our next generation of manufacturing engineers or process engineers in manufacturing?
The pressure's on, but the pressure was always on us too. They have the tools. The tools are there to learn so much faster, to get those answers, to pull the data down and see what's going on. They just have to be aware of what's going on. These kids nowadays, they know how to use this stuff. They know what's going on to get those answers. So I think if we could steer them in the right direction, they can pick this stuff up pretty quick. It's just we got to give them a chance. Get them out there, give them a chance.
That sounds fantastic advice. And I totally subscribe to that because there's nothing more exciting for me than to be able to take on a couple of interns or co-op students and really show them what manufacturing is about. Because I find that nowadays, yeah, engineering schools don't quite emphasize how much fun and how challenging it is to work in a manufacturing environment. It's sexy to be an AI engineer, but to work in the world of manufacturing that you and I built our career on is such a satisfying journey. Manufacturing is also one of those things that most people look at and go, "Oh, that's not sexy. You're not going to make huge money and get rich." I beg to differ. I've seen some very successful manufacturing guys. It's certainly there because I don't think consumerism will ever go away.
We still got to get back to the apprenticeship programs and that kind of thing that unfortunately we've got away from. But I mean, I do a lot of work with my younger kids with Boy Scouts and Cub Scouts and that kind of thing. And there's been a few times that I've taken them for a tour down to the factories, and the wide eyes going, "Wow!" You start the machines running, those robots running. It just you got to get them exposed a bit, see what's going on, and those electronic factories are cool. Come on, man. Anytime anybody walks through, they haven't seen them before, you see their eyes light up. They're a cool place to.
That's right. Yeah, yeah, they are very cool. That's why I can't get away from working in manufacturing. I've just got such a passion about it. Well, Phil, it's been a very fun conversation. Thank you very much for sharing a lot of your insights and great input on this topic. If we wanted our audience to connect with you, what's the best way to chat with you or ask you questions?
You can find me on LinkedIn. Send me a note. Happy to chat anytime. Happy to share my knowledge. You guys, anybody looking for a little bit of insight on where they're going and what's going on, give me a ring, give me a niggle. Not a problem.
All right, I'll make sure I include that link. And to the audience, Phil is definitely my go-to source when it comes to all the great things about manufacturing automation. So definitely drop him a message or connect with him on LinkedIn. So with that, well, thank you very much, Phil, for joining this episode. I had a really fun conversation with you.
Oh, it was great. I enjoyed it, Kent. Thank you very much. Good to catch
All
up.
right, and out to our audience, thank you for listening. We hope you enjoyed this episode, and we'll catch you in the next one. Drop us a comment or feedback as usual. Give us a like, and until the next
Hitting
one,
those thumbs up there.
you bet.
Always good.
Thank
Always
you.
good stuff.
Bye, everyone.